In this short film, I would like to show how to create SteelTower in Eigenform program. First, let's look at the assumptions for our project. Let's imagine that we would like to build our structure from different segments. Slope in each segment will be different. Also, types of diagonals and number of diagonals levels can be different. We see that there are a lot of variables here, but thanks to parametric approach, we can create easily many variants of the same structure. We start our project by adding new profiles to sections database. I select a few L-shaped profiles from standard steel profiles database and I add them to our project. It is necessary to do it, otherwise we wouldn't be able to use them. Also, at the beginning, we can change some default settings. Here, I change the type of spread footings. By default, I profit from the option that these footings will be generated automatically on the unsupported column. Let's choose contour of our tower. I select prismatoid, I choose 3 sides and I set 3 meter as a side length. In Eigenform, each mass by default has upper slab switched on, so I switch it off and I assigned one of previously added profiles to corner columns. Then, as tower will be sloped, I choose advanced shape and I set dimensions of mass upper contour in relation to lower one. Next step is to define diagonals. I select all external edges of the mass, I set number of diagonals, I assign profiles to them, type and material. Program allows to select appropriate type of diagonals. A few types are available. Assigned type can be freely changed in later phases of the design. Let's come back to our assumptions to see how many segments we need to have in lower part of the tower. So let's say there will be 3 segments. These segments are modeled by stories. By default, middle slabs are switched on, so I switch them off, as in our steel tower we have only bars. Then finally we can adjust the height of this lower part and we are ready with the first mass. Now I use another useful option of Eigenform software, namely mass copying. To locate properly this middle part of the tower, I use alignment options. I make vertical and horizontal alignment in relation to first mass, and by choosing an option equal dimensions, I align lower contour of second mass to upper contour of first mass. Now I can make different slope by upper contour scaling. Finally, I can add the last part of my tower by copying the middle part and making appropriate adjustments. So, as previously, during copying, I also copy the whole parametrization. I need to change the name of mass in alignment options, scaling coefficients of upper contour, and we will have all 3 parts of our tower. Let's look once more at our assumptions. At this moment we can decide about heights of masses and also number of stories. These stories are important because we would like to have later different profiles. So just now I will show how to easily achieve this effect. In Eigenform software there is an assumption that parametrization of all stories in one mass is the same. So, to have different profiles, I will use an option divide mass according to floors. As a result, program creates new mass for each story and automatically make mutual vertical and horizontal alignment. Now we can delete the original mass. We can start differentiation of steel profiles. So I select L-shaped profiles for corner columns for second level. For better visualization, I switched on an option Automatic Coloring of Sections. Thanks to it, different sections have different colors. As we assume that all sections on each level will be the same, I select all mass edges on second level and I assigned the same L-shaped sections to diagonals. Then I can do the same operation for third level, so change of sections for corner columns and change of sections for diagonals. At every moment on 3D view we can verify if our parametrization is correct. Let's look again at our assumptions. Now I would like to set appropriate number of diagonals levels for each segment of our tower. In this case there will be 3 levels, so I make multi-selection of 3 lower masses and I set 3 stories. It can also be treated as parameter, and this setting can be freely changed later. Now I use again an option Divide Mass according to floors for middle part of the tower. After deleting the original mass, there is a problem with alignment, as old mass name used for parametrization doesn't exist. So we should restore correct alignment. To do it, we need to select lower segment of middle part of the tower and align it to upper segment of lower part of the tower. After doing it, geometry of the tower returns to previous state. To finish our model, we need only to repeat some of previous operations. So first, I will assign appropriate profiles to middle part of the structure. As previously, I will be selecting next masses, then assigning L-shaped profiles to corner columns, and then assigning L-shaped profiles to diagonals. In this middle part, we have 4 segments with different profiles, so we need to perform the above operations 4 times. Here we can also notice that parametrization window in Eigenform software is flexible. At every moment we can wrap any part of interface and focus only on required elements. And now we are very close to final model. So let's verify assumptions as far as number of diagonals levels is concerned. For middle part of the tower we will have 4 levels, so as previously they will be modeled by 4 stories. It is sufficient to make multi-selection of all masses representing the middle part of the tower and set appropriate number of stories for them. For the last part of the tower we don't need to use the option Divide Mass according to floors, as we will have only one steel profile here, so we can use original mass. To have proper model we need only to make appropriate alignment, as originally this mass has been positioned according to mass which has been deleted. So I choose correct mass, namely upper mass from middle part of the tower, and assign L-shaped sections for corner columns and diagonals. Now the last verification of project assumptions. For upper part we should have 8 levels of diagonals. It will be the last operation in geometry building process. I set 8 stories for this mass and we can assume that tower model is finished. Before defining wind load case and sending the model to Autodesk Robot Structural Analysis, I would like now to emphasize the power of parametric model. Namely, if we would like to change the geometry of tower, we can do it quite easily. For example, we can change the height of segments. To do it, it is sufficient to make multi-selection of chosen segments and set another height. Thanks to appropriate vertical alignment relations, the whole model is automatically rebuilt. Also, we can change basic contour dimensions, and thanks to appropriate horizontal alignment relations, the whole model is also automatically correctly rebuilt. Finally, we can change type of diagonals. Here, I change this type for lower part of the tower. X crosswise cut means diagonals will be divided in the middle during export to Autodesk Robot Structural Analysis. In Eigenform software, the user can define various load cases, for example, wind loads. Wind load can be defined by pressure or by wind speed. Additionally, a wind profile can be defined using any curve. In Eigenform, curves are part of sections database, and besides wind profile, they can be used for contour definition and roof definition. When wind load case is defined, we can generate final load records, which depend on real geometry of used profiles. We can see the result of this generation by switching on 3D view the engineering model on. Now I will export the whole model, including wind load records, to Autodesk Robot Structural Analysis program. The connection with robot is realized via API interface. Eigenform software generates RTD file. When generation is finished, I run Autodesk Robot Structural Analysis and open just saved file. First, I switch on the visibility of profiles to verify if they have been correctly exported. Steel sections database used in Eigenform is compatible with Eurocode base of Autodesk Robot Structural Analysis. Next, I change layout for loads, and here we can see that also wind loads have been correctly exported. Generally, models exported from Eigenform to Autodesk Robot Structural Analysis are calculation models, and they should be ready for calculations without any specific actions. So I run calculations, and to verify results, I go to Results Layout and display axial forces for self-weight and wind load case, which are according to our expectations. Summarizing, parametric approach adds significant functionality to traditional modeling, and in many projects can definitely accelerate design process. Thank you very much for your attention.